All right, folks, today we're going to be talking about dimensional analysis, which is just converting between units and rates. We're going to learn a helpful tool to help us convert units and rates in the form of a T-chart. But before we do that, I want us to try out this warm-up problem that kind of touches on the content of our last notes on ratios and proportions. Go ahead and pause the screen and try to do this first part on your own. Hopefully you're able to see that the two units that we're comparing in the scale are inches to miles. That's what I made my little reminder over to the side as. Then I set up a proportion. 2 inches goes with 500 miles, just like 4.3 inches goes with we don't know how many miles. Cross multiply and you get 1,075. Hopefully you're thinking that answer is not complete because I left off units. Shame on me. 1,075 miles. Now, if we wanted to convert those miles into feet, we would have to know an additional piece of information. We'd have to know what? We'd have to know how many feet there are in a mile. So if I told you that there are 5,280 feet in 1 mile, we could use that to convert the 1,075 miles. We're going to use even though this is a really basic problem, we're going to use the T-chart that we're going to use in the notes to help us out. So we know that we have 1,075 miles. And we want to get rid of those miles. So we want to get rid of the miles so we can turn it into feet. In this next part of the T-chart, we're going to put that 1 mile is equal to 5,280 feet. We're going to write it as a ratio there. Now, it's important that I put this miles in the denominator because the miles in the numerator will cancel with it. So when you have something in the numerator and something in the denominator, those units will cancel. Then we will multiply straight across. 1,075 times 5,280 gives you 5,676,000 feet. This little T-chart here is what we will be using as we do more difficult problems. This method of converting between units is what we call dimensional analysis. The goal of dimensional analysis, we want to try to eliminate or cancel units by making sure that the units are in the numerator and the denominator to get to the units that we want. So we're going to start out with some basic examples here. In this first one, we want to find out how many seconds there are in 3 days. I always think to myself to make a little map of how I'm going to go from seconds to days off to the side. We're starting with days. We cannot immediately jump to seconds. We have to go from days, convert those into hours, convert the hours into minutes, and then we can convert the minutes into seconds. This gives me a map for how to set my T-chart up, and it makes it a lot easier down the road. You always start in your T-chart with what you're given. We are given 3 days. This one, as you can see, we have to convert a lot of units, so I'm going to make my T-chart nice and long. I want to cancel out days. I want this to be gone. So I'm going to put days in the denominator in my next ratio. We know that 1 day is equal to, next unit we're going to bump to is hours. 1 day is equal to 24 hours. So in this piece right here, we're writing a ratio that's an equality statement. Days compared to hours. Now we're in the units of hours, but we don't want to stop there. We want to continue on and go from hours to minutes. We want the unit of hours to cancel, so we're going to put hours down below and minutes up above. Then think to yourself, what is the conversion unit between hours and minutes? We know that 1 hour is equal to 60 minutes. Just like the days canceling before, the hours now cancel because they are on one's in the numerator and one's in the denominator. We are now in the unit of minutes, but we don't want to end in minutes, we want to end in seconds. So we're going to put minutes down below so it cancels, and seconds, the unit we want to get to, up above. Think to yourself of the conversion between minutes and seconds. 1 minute is equal to 60 seconds. The minutes in the numerator will cancel with the minutes in the denominator, and we are left with our final unit that we want, which is seconds. You'll now go back to the numbers and multiply straight across. Multiply, multiply. If we do 3 times 24 times 60 times 60, we get 259,200 over 1 times 1 times 1, which is just 1. So we don't need to do anything there. Just make sure that your answer is in your final unit of seconds. We'll try another one right beneath there. Peyton Manning, a retired NFL quarterback, had 71,940 passing yards in his career. We want to find out how many miles that is. Again, just like in the problem before, we're going to make a little map to remind ourselves how to get from yards to miles. We're going to have to go from yards, then to feet, and then from feet, we can go to miles. Start out always with what you are given. In this problem, we are given 71,940 yards. We do not want this problem to end in yards. We want to cancel out that yards. So we're going to make sure that yards goes in the denominator. And our next unit, according to our map, is feet. So we're going to put feet right above there. You should know that 1 yard is equal to 3 feet. These yards will cancel, and now we're in the unit of feet. But we want to go from feet to miles. So now we put feet in the denominator of our next ratio. We want to change it to miles. From the problem that we did before, we know that 5,280 feet is equal to 1 mile. The unit of feet will cancel, and we are left with our unit that we want to end with, which is miles. Just like before, you're going to multiply the values, the numbers, straight across. Multiply the numbers straight across. $71,940 times 3 divided by 1 times 5,280. This division bar is telling us to divide. We divide it out and we get 40.9, and make sure you're labeling your answer in the final unit, miles. Pause and rewatch if you're confused by either of those two problems, and make sure to log back into office hours if you're confused by that. On the back part of the notes, we're going to practice using dimensional analysis to help us convert rates. The only difference with rates is these problems will have 2 units to convert. So a rate is something like miles per hour or cost per yard. In this first example, we're told that Abby is on a road trip to Louisville from Nashville. She is driving at a rate of 55 miles per hour. We want to convert her rate to inches per second. Just like in the problem before, we are going to make a little map to remind ourselves what units we need to jump to in order to get to our final answer. So if we look at miles, As you can see from the problem, we want to go from miles to inches. We can't directly go from miles to inches, so we have to go from miles to feet, and then we can go to inches. You'll notice that we have another part that we have to convert, hours to seconds. So we're given hours. We can't directly go from hours to seconds. We have to go from hours to minutes to seconds. So we have two pieces that we have to take into account. We will still use our T-chart, just going to be a little longer than before. We'll convert 1 unit at a time. Take always what you have been given in the problem, and that goes in your first part of your ratio. So we are given 55 miles. When it says per, you put that whatever's after per in the denominator. So 55 miles per hour. The first thing we're going to do is convert the miles to inches. So we need the miles to cancel out. We'll put the miles down below, and we're going from miles to feet. We know that 1 mile is 5,280 feet. The miles cancel. We are now in the unit of feet, but we need the feet to cancel to go to inches. So we will put the feet in the denominator, inches in the numerator, and think about your conversion. 1 foot is 12 inches. Feet cancel, and at this point, circle inches. We are in at least one of the units that we want to end in. Now we need to go back and deal with this hours. We need the hours to change first to minutes. Notice how hours is in the denominator. So we need to put hour in our next ratio in the numerator in order for it to cancel. We want to change hours to minutes. We know that 1 hour is 60 minutes. This hour that was in the denominator back here can now cancel with the hour that's in the numerator, even though it's a far way down on the T-chart. We're in minutes now. We need to go from minutes to seconds. The minutes is in the denominator, so we need to put minutes in the numerator, and we're going to seconds. We know that 1 minute is 60 seconds. The minutes cancel. We end in our final unit that we want to be in, which is seconds. Just like before, once we get in our final units, we will multiply straight across, multiply those numbers straight across as well. So we have 55 times 5,280 times 12 times 1 times 1. Going to give us a large number here. In the denominator, we have 1 times 60 times 60. In your final step, you would divide these two values, and you get 968 inches per second. Box your final answer. So rates work in the same way, except you have 2 units to convert. Make sure that you're being very careful about where you place things in the numerator and the denominator so that they cancel with one another. Let's try another one. Ashlyn is on a road trip from Louisville to Nashville. He is driving at a rate of 60 miles per minute. Who is driving faster? If we want to compare these two people, Ashlyn and Abby, we need these miles per minute to be in the same unit as inches per second. So we're going to change miles to inches, and we're going to change minutes to seconds. So off to the side, just like you've done before, make sure you're making a map. We're going from miles. What do we need to go to? Inches. So we first need to jump to feet, and then we can go to inches. And then we're given minutes, but we need to go to seconds. Put the rate that you're given back here in as the first part of your T-chart. So we have 16 miles per minute. I'm going to convert the miles to feet first. Miles is in the numerator, so I need it to go into the denominator to cancel. Feet up top. 1 mile is 5,280 feet. Now we're in feet, we need to go to inches. Feet needs to cancel, so it's going to go on the opposite side of the fraction bar, inches up top. 1 foot is 12 inches. The feet cancel, the miles cancel. We are in inches now, which is where we want to be so we can compare ourselves to Abby's trip. Now let's go back and change minutes down here into seconds. Notice that minutes is in the denominator, so in the next part of our T-chart, we need minutes to be in the numerator in order to cancel, and seconds needs to be our final unit down below. You know 1 minute is 60 seconds. The minutes cancel. We are now in our final unit of seconds. Multiply straight across, multiply straight across. 16 times 5,280 times 12. Should get your final answer is 16,896 inches per second. So you can say that Ashlyn is driving way too fast and is driving faster. Let's do one that is not miles per hour. Let's do one that's dollars per yard. So we can see some different units here. Old Navy is trying to buy some fabric for their new collection. Fabric costs $4.99 per yard, so we're comparing dollars to yards. How much is Old Navy paying for fabric in cents per inch? So in this problem, make a little map to the side. We're changing dollars to cents, and we're changing yards to inches, which you cannot necessarily, I guess you can in your head, but you can go from yards to feet to inches. Make your T-chart. Plug in what you're given. We are given $4.99 per yard. And I'm going to start by changing dollars to cents. So we know that $1 needs to cancel out down below is 100 cents. The dollars cancel. We're left with our unit here of cents. Similarly, we're going to change yards to feet. Notice how yards is in the denominator, so we need to cancel it out by putting it in the numerator. We're going to change it to feet. 1 yard is 3 feet. The yards cancel. And then we need to change those feet to inches. 1 foot is 12 inches. The feet cancel. You end with your unit that you want to end in, which is inches. Multiply, multiply. So we have 499 divided by 36, because 12 times 3 is 36. And you should get 13.86 cents per inch. Make sure you label your final answer. I want y'all to pause the screen and try this last problem on your own. All right, if you have done that last problem, make sure you converted the feet to miles, and then the seconds that were given to minutes, and then the minutes to hours. Your final answer that you should have gotten in the end is 120 miles per hour, which to me sounds very scary. Pause and rewatch anything you need. Log back into office hours if you have questions.